In this use case, a designer revisits a product for a new application and aims at reducing the climate change indicator in the process. The initial material for the baseplate had been selected several years ago. There is limited information as for why this one had been picked, but the initial design was exposed to harsh environments. The new design will not be exposed to such conditions, but need to sustain similar mechanical constraints. From MI Materials Gateway and Creo, the designer runs a sustainability analysis to calculate the climate change and embodied energy of the initial design. She can see that the baseplate part is the largest contributor to climate change. She renames the BOM and saves it as the baseline for comparison later. A material engineer worked on finding suitable alternatives to the baseplate material and shared the results in a favorite list dedicated to this new project. The designer loads the favorite list in her CAD environment, identifies the new material, checks its properties, and assigns it to the baseplate. She then runs the sustainability analysis with the new assignment. She can now compare her baseline design to the new one and use the different views available in the dashboard to analyze the impact of the changes to the sustainability indicators of the product before going further with the design and potential mechanical simulations to validate the choice, alter the geometry, or substitute additional materials.